Welcome, Calculus AB. This is lesson 6.2, Riemann sums. Let's begin. So, we've been talking about integration. Some functions can't be integrated. And so I might give you write a function, but it can't really be integrated by one of those formulas that we know, or even the ones we haven't learned. Like there's no formula for it. So I can't just like do the definite integration that we've done before. But sometimes we also have functions that really aren't a function. You're given some kind of curve, but it's not really a function. It's just like some data points in a function, and we're kind of approximating it. So, but we still have some kind of chart right here with a curve going on. Well, instead of using our integration methods we already done, we can approximate areas. So that's what Riemann sums are all about. We are going to approximate the area under this curve. And one method of approximating is just making the area a bunch of rectangles. And that's Riemann sum here. So take this curve right here, goes up and it does some squiggliness and goes down and goes up. So we don't have a function for this, but we know the data does this kind of stuff. So I don't have a function to model this, an algebraic function. Instead, I'm going to say, well, I know it goes from 0 to 10, and I can approximate it by chopping it up in a bunch of rectangles. So what we did here in this case is we made rectangles, and every rectangle has a width of 2. And then every rectangle is based off some height. So there's a few different ways of doing these kind of rectangles. One rectangle is we're going to call this the midpoint Riemann sum. We're going to take the length of the rectangle, take the middle of the y values, the middle x value, and then put the top of the rectangle at that y value. So we're basing the height off of that point. And this rectangle is basing the height off that point, or of this point, or down here, and then or up here. So these are midpoint Riemann sums. We're building rectangles off the midpoints. Now, so what we'd have to do to approximate this area is we just add the area of the rectangles. Well, the area of this first rectangle is the height 2 times the base 2. So I'm going to say the area is approximately equal to, so I can say integral from 0 to 10 f of x dx is approximately equal to 2 times 2 plus 2 times the height here is 5 plus the height here is 3, so 2 times 3 plus 2 times 1 and plus 2 times 3. So we add up all those areas. It's 4 plus 10 plus 6 plus 2 plus 6. And you get 14, 20, 22, 28. So my approximate area is 28. Now, sometimes we don't base it off the midpoint. We can base it off the left hand. So we're going to build a left-hand Riemann sum. So I'm actually going to draw this. So the rule here is this time we're saying 5 rectangles of equal width. That's not always equal width. And we're going from 0 to 10, so that means each width has to be 2. So instead of this, so we have a rectangle here, we have a rectangle here, 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 and here. So these are 1, 2, 3, 4, 5 rectangles. So it's going to be based off the left-hand side of the rectangle. So the left-hand point. So the left-hand point is here for this rectangle. It's here for this rectangle. It is here for this rectangle. For this rectangle, it's here. And then for this rectangle, it's here. I want to show you what those rectangles look like. So let's do this one first. So left point right here, the rectangle is going to be this shape. And I'll fill it in like that. For the next rectangle, it's going to be based off this point. It's going to fill in like that. For the next rectangle, we're going to do off this point. So I'm going to go across and down perfectly. It's going to fill in like this. The next one, we will do this point, and it fills in like this. And then for the last one, the rectangles here, it actually has no height. It's just flat. Notice that it's approximating the area. You know what the area actually is? It's like all this shape right here. But sometimes it goes over the area rectangle, sometimes it goes under. We're approximating. So let's add the area of all these rectangles. So I'm going to say the integral from 0 to 10 f of x is approximately equal to the area of this one, which is 0 times 2, plus the area of this one, which is going to be the height 4 times 2, plus the height of this one, which is also 4 times 2, plus the height of this one, which is 2 times 2, and then the last one, which is also 2 times 2. So we're at 0 plus 8 plus 8 plus 4 plus 4. That is going to add up to 24. So notice that was different from what we got the last time we had a 28. Different way to approximate. Now, right hand. So instead of going off the left-hand point, we're going to go off the right-hand point. Again, same length of rectangles, 2 width. So this point for this rectangle, 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 and then right is going to be this point for this last rectangle. So what do those shapes look like? This is going to be the right hand right here filled in. And the next one, the right hand is going to be this point. So that'll be the next one filled in. And then the next point's going to be based off this right side. So it'll be this rectangle. And the next one's going to be built off this height. And the last one right here is going to be built off this height. So let's see what these areas add up to. So the area of this rectangle right here is 2 times 4, which is going to be 8. Area of this rectangle is also 8. This one's 4. This one's 4. And this one is 5 times 2 is 10. Adding all those up, that adds up to 34. So different approximations gave us different answers, different ways of doing it, and that's fine. These are all approximations. Some are better than others. Now, when you're doing these rectangles, sometimes you can have negative rectangles. So that means rectangles that are below the x-axis. And also, sometimes the widths aren't the same distance. So we're going to take this function right here, 2 to the x minus 8, looks like this shape, from negative 10 to 5. And we're going to use 5 right-hand rectangles whose widths are determined by the intervals separated here. So we're going to go x equals 10 this point, x equals 4, x equals 2, x equals 3, and x equals 5. So we're going to have different sized rectangles. Now they're going to be based off the right-hand point. So what do those rectangles look like? Let's start on the right hand. This rectangle is going to go all the way over to this next point and then go down. So it's going to be this area right here. Now, this next rectangle right here is going to be based off of this point, and it's going to go all the way over. But, it's going to be flat line there because we don't go down. Now, the next line, it's, no, that was my bad. That's not even right. Wait, no, that's right. Okay, this next one is the right-hand point here, and it's going to go all the way over to here. So watch, it's going to be this area. It's going to be this rectangle. It's actually going to look like this. I tried to draw straight. Didn't really work. It's going to be this area right here, and that's actually going to be negative rectangle land right there. And then the last rectangle, this one's going to be bait off the point right here. Let's change the color on that to red. So it's also going to be a negative rectangle right here. Now, what are the area of all these rectangles? I'm going to use my calculator right here. So, I can tell you what the widths of each of these are. You can tell that the width of this one from negative 10 to 4 is 6. And the width of this one from negative 4 to 2 is also 6. The width of this one's 1, and the width of this one is 2. All right, what are the heights? So the heights of this rectangle, remember, it's the right hand, so it's based off, this one is based off this corner. What is the height right there? Well, I'm going to have to plug in negative 4 into that equation. So I'm going to use my calculator. This is going to be 2 to the negative 4 power. Actually, let's just graph this. It'll probably be better if we do this. So I'm going to graph this equation, 2 to the x minus 8. And here's our graph. And I'm going to use my trace function. I'm going to trace to negative 4. And I'm told y is, this point right here is negative 7.938. I'm going to round up. And then the next point right here at 2, well, I'm going to trace to 2. And this is going to be negative 4. And then this is 0. And then the last point is up here when x equals 5. So when x equals 5, we're at 24. So to find all those areas, the area of this first rectangle, this is negative area, remember. So it'll be 6 times negative 7.938. And then plus the area of this one, which will be 6 times negative 4. And then area of this rectangle, which is 0. And then plus 2 times 24. And if you add all those up, you're going to get your answer. And yeah, I could do this. Let's go through the calculator. You're going to go 6 times negative 7.938 938 plus negative 6 times 24. So negative, or 4, negative 24 plus 48. Oh, didn't like that. So, okay, I'll go minus. There. So my answer to all that for the total area is negative 23.628. So yes, you can have negative area in approximation. And we're done.